So far, we've seen trig identities that deal with reciprocal relations. We'll now review these types of trig identities, and then we'll introduce some new ones. First, we have the following reciprocal identities. These relations arose from the definition of each trig function. We're going to go ahead and add two more, and it's the following fact that tan theta is equal to sine theta divided by cosine theta, and cotan theta is equal to cosine theta divided by sine theta. A quick check that these are true is if we assume that tan theta is equal to sine theta cosine theta, and if we already know that cotan theta is a reciprocal of tan theta, both these facts imply cotan theta is equal to cosine theta divided by sine theta. Let's now introduce some more identities. The first one, sine squared theta plus cosine squared theta is equal to 1. The next one is tan squared theta plus 1 is equal to secant squared theta. The final one is 1 plus cotan squared theta is equal to cosecant theta. Let's assume this fact, and we'll show that tan squared theta plus 1 is equal to secant squared theta. So proof of star. Starting off with sine squared theta plus cosine squared theta is equal to 1 if we divide both sides by cosine squared theta. Then we see that the cosine squared thetas cancel out and we're left with 1. So this will become a sine theta divided by cosine theta raised to the second plus 1 is equal to secant squared theta. And since sine squared divided by cosine is tan theta, we get tan squared theta plus 1 is equal to secant squared theta. So you don't need to remember all these. The only Pythagorean identity that you do need to recall is this first one, because the other two can be recovered from this first one rather quickly. A useful application of these identities is if we want to write a trig function in terms of another. Let's write cosine theta in terms of sine theta in the third quadrant. Writing out the Pythagorean identity, we have that cosine squared theta plus sine squared theta is equal to 1. And we want to write cosine in terms of sine theta. So let's go ahead and solve for cosine theta. We'll do this one step at a time. And again, taking the square root, we'll have two options. Cosine theta is equal to plus or minus the square root of 1 minus sine squared theta. Now, because the square root is only defined for positive numbers, we also know that 1 minus sine squared theta is always going to be greater than or equal to 0. That means when we take the square root, we'll get a positive number out. And so we need to choose between either this plus or minus. And a quick tool that we can use was the little graph that we saw earlier, where each trig function is positive. So in the first quadrant, all trig functions are positive. The second one, sine is. The third one, tangent is. And the last one, cosine is. Maybe a quick trick to remember this is that all students take calculus. So what this chart's telling us, in the third quadrant, both sine and cosine will have negative values. Since we want our function to have negative values, we want to choose the negative here. So writing this out, we have that cosine theta, written in terms of sine theta, in the third quadrant is going to be equal to a negative square root of 1 minus sine squared theta. This is the solution. In example number 4, let's find the values of the trig functions of theta given the fact that tan theta is equal to 4 divided by 3 in quadrant 3. Let's sketch out the information that was given. Drawing our unit circle, we know we're living somewhere in the third quadrant. So maybe our angle is given by theta. And what we do know is that if we look at the reference angle, this is going to be the angle between our green ray and the x-axis. Call it theta bar. This angle determines a right triangle. Let me go ahead and redraw this triangle. Where this angle here is theta bar, the opposite side has length 4, and the adjacent side has length 3. And the radius, or the hypotenuse of this triangle is not known. So we can go ahead and solve for the hypotenuse real fast. This is again given by the Pythagorean theorem. We'll get 3 squared plus 4 squared is equal to r squared. We get 9 plus 16 is equal to r squared. So r is equal to the square root of 25, and this is 5. We now have all the sides of our triangle, and we can go ahead and find all the values of the trig functions. We'll have that sine theta is again opposite divided by the hypotenuse, so this is 4 divided by 5. And now we have to be aware of our signs. So this 3 is a negative number, this 4 is a negative number, and the 5 is a length, so we'll leave that alone. Since we have a negative number, this is going to have a negative value. Now cosine of theta is adjacent divided by the hypotenuse, which is going to be negative 3 divided by 5. Tan theta is given by 4 divided by 3. Cosecant theta is given by the hypotenuse divided by the opposite, so 5 divided by negative 4. Secant theta is the reciprocal of cosine theta, so we'll get 5 divided by negative 3. And cotan is the reciprocal of tangent, so we'll get 5 divided by 4. Excuse me, cotan should be 3 divided by 4. So this is a 3.